Alrighty, welcome back everybody. Today we are going to be working with 7th grade math with our focus on angles, areas, and volume. Alright, so let's get right to it. Looking at this, I mean, if it sounds like if it's areas, we're dealing with geometry, right? Yeah, calculators. I see angles in there, more angles, areas of circles, more angles. Oh, we got this right here. Oh, they love this picture right here. It's like one of the favorite ones in 7th grade or middle school, really. Okay, for the area. What is that? Okay, we'll deal with that when we get there. No problem, we'll get there. And then looks like wrapping paper, so that's area. Okay, we got this. It's not that bad. All right, so let's get into this with this shape. Like I said, they love this shape in middle school. Let me go ahead and get my calculator ready because I know I'm going to be using it. So enter the area of the figure in square inches. So let's see, our basic strategy that most of us will do is we're going to split it into two rectangles. So we could have gone that way or we could have gone that way. I think I'm going to do the purple one because I don't have to do much like figuring out here, and you'll see what I mean in a little bit. So if I enter the area, I have the area of the long rectangle. And rectangles, the area is length times width, right? Or base times height. And this one, like I said, I'm going to stick to this one because I have both a length and a width. I got 12 and 3. Then I'm going to add the other piece. So I'm going to add this piece right here, which almost looks like a square, but it's not because the length and the width is going to be 6 by 8. Nah, just kidding. So I take that back. We are going to have to figure this out. So let's see, what am I talking about? Some of you guys already have that in your heads. Well, if this whole piece is 8, and then over here I got this piece is 3, well, I'm going to take out that piece. So in other words, to get that left over on the other side, it should be 8 minus 3, which is in fact 5. So my length will be 6. So there's my L, right? L is 6. And my width will be 5 here. All right. So I thought I was going to get away with it, but I didn't. So good thing I caught it. All right. So let's see. Let's find the area of the first shape. Area equals length times width, which means I have 12 times 3. Plus the area of the second one, which is also length times width, which in this case is 6 times 5. All right, so what do we got now? In this case, let's use our calculator. I got 12 times 3, and I got 36. And then I got 6 times 5, which gives me 30, yup. And now I can add both of these. So I know I can do the mental math. It should be 66. Let me confirm that. 30 plus, see, not minus, 30 plus 36 is in fact 66 square inches because we are finding the area. All right, the circumference of a circle is 48.26 centimeters. That's nice. Enter the radius of the circle in centimeters. Round your answer to the nearest hundredth. Okay. So let me think about it. The area of a circle is pi r squared. But they don't want that. But that's something you guys, a lot of you remember. Okay, you usually like to use it in there. The circumference is just the distance around the circle. So that's not the area. The circumference is the pi times the diameter. So in this case, what did they give us? Well, they gave us the circumference already. So the circumference is going to be in centimeters right there, because again, circumference was given. Well, we know what pi is. Pi is 3.14. And in this case, we're going to find the diameter. So let's use substitution here. I'm going to use 48.26 equals 3.14 times the diameter. So how do I solve for the letter D, or the diameter? Well, if I am multiplying times 3.14, I am going to divide by 3.14. If I do it to one side, I'll do it to the other. This will give me one diameter. And again, if you've heard me, when I say it cancels, I say it's one. So I got one diameter. And then let's use our calculator. 48.26 divided by 3.14. And I get roughly 15.36942. And I write as much as I can. Okay, just to be safe. Now I want the radius. So remember that in a circle, the diameter is from one end to the other and it goes through the center. Well, to find the radius, I have to cut the diameter in half. So I'm going to get this piece and this piece from the center to the edge. So in other words, the diameter is twice the radius. So if my diameter is 15.369422675, I'm going to take that answer. Notice I pressed the answer. You can tell a little bit right there in blue. Can you see it says my answer? So I'm going to clear that, press the answer button, and I'm going to divide the answer by 2. That way I don't have to type in the whole thing. And if I divide by 2, I get the radius to equal, what does it say, 7.6847. Where do I have to round to? I have to round to the nearest hundredth. That is my 2 decimal places. So what does rounding mean? If the third number is less than 5, I'm going to keep it at 7.68. If the third number was 5 or greater, I would have had to round up from 68 to 69. Alrighty. Shrink that a little bit. Alright, the diameter of a circle. Okay, so now it's kind of the same thing that we're dealing with. So I'm seeing a pattern here. So we're dealing with circles right now. So the diameter of a circle from edge to edge is 27. Again, if I want the area of a circle, then that means that the area, as I said earlier, is pi r squared. Well, I need the radius. So how do I find the radius? I just explained that. If the whole thing's a diameter, the radius is going to be cut in half. So let's take back our calculator. And I'm going to take 27 and I'm going to cut that in half. So that means that my radius is 13.5. So that's perfect. So I'm going to put area equals pi. My radius, because I am substituted, I'm going to put a parenthesis around my letter. And I'm going to put a 13.5 in there. Now here's what's interesting. This is where you got to be careful. Okay, you're going to notice on your calculator, because some of you guys probably did this already, your calculator has a pi button. So the calculator is awesome because all we got to do is copy exactly what it says right there, and it should give us the answer. Well, if I put pi, notice it gives me as much as it can pi, right? Instead of 3.14, it gives me more numbers. So it actually put in a bigger number, okay? Because I stopped at 3.14 in the end. But the button's there. I'm just going to use the button. Then there's a parentheses. I got 13.5. Close the parentheses. And do you see the square button? Which one do you think I'm going to use? Can you tell? I'm going to use that 1a to the 2 power, or the exponent of 2. So notice, does this look like that? Yes, it does. Okay, so once it looks like that, I am happy. What is my answer? After I click enter, my area is roughly 572.5552611. What do they tell me to round to? They said round to the nearest whole number. Okay, no problem. I could do that. So if it's 572.55555, my nearest whole number is the 2. So I got to check the number after. What is it? It is a 5 or greater number. So that means I'm going to take the 572 and I'm going to round up. So that gives me 573. Now here's the thing, okay? Again, I'm just using this for practice, right? I do remember that some of the questions will tell you whether are you going to use pi or are they going to tell you to use 3.14. So let's see what the difference would be. Just a little mini lesson, okay? Right here, it didn't tell me, so I decided to use all of pi. Let's see how things would change. So instead of that, I'm going to say, okay, well now it's 3.14 times 13.5 squared, right? There's my pi r squared. So let's write that instead, 3.14 parentheses, 13.5, close the parentheses to the power of 2. And now my answer is 572.625. So if I round to the nearest whole number, oh, I wrote it wrong, 265. If I round to the nearest whole number, guess what happened? Can you see already? My next digit or decimal place is a 2. If it, notice how that is smaller than 5, so that would stay. So this one, I could also put 572. Which one would be correct? So here's the issue. Normally, right, because I've seen answer keys from the state exam, right, on different problems with pi, okay? They'll say or, and they have the word acceptable, okay? So they will accept either 573 or 572 because they didn't tell you specifically what to use. So let me just go again. Sometimes they will tell you what to use. So is it 3.14 or pi? So just keep that in mind. You got to read the question. Maybe we'll come into one down the road, but just I'm already thinking ahead, okay? Because that's a big one right there. You did everything correct, and it would just suck if you just, if you didn't follow the instructions correctly. All right, next one. The figure below is a prism. So can you tell it basically looks like a box, right? So it's a prism that is made up of 1-inch cubes. Can you tell the 1 inch right here? Right? Can you see it? 1 inch. And there's the other cube, and there's like a bunch of cubes that are stacked together. Can you tell? So here's another one, right? Can you see them? Stacked together. And then I can go like this. Right? Can you tell? That was the best as I could do with my little 3D imaging right there. So enter the volume in cubic inches of the prism. Well, here's the thing that's interesting. I'm going to do this 2 ways. The first way is visually. I'm just going to count, right? Can you visually see how many cubes there are? Well, in this case, can you tell that there were 2 cubes right there? So this one's 2, and this one has 1, 2, 3, 4, 5, 6. So notice that on the bottom, I have 1, 2, 3, 4, 5, 6 cubes, right, that I can see. And then I stacked it backwards twice, so that gives me 12 cubes. Well, if this is 12 cubes, well, guess what this is? This next piece is also 12, then another 12, and then another 12. So what does that give me? Well, that gives me 12 plus 12. Let me use a calculator. 12 times 4, right? So that gives me a total of 48. Okay. So here's the other thing you should know. This essentially, because it is volume, let me draw this as a rectangular prism. One of the things you should have done already this year quite a bit is learned the volume of a rectangular prism. So the volume of a rectangular prism, they give you a ginormous hint here. It is in cubic inches, and this is why these are a little mini lesson, okay? It's a great hint, so please pay attention to this. So if you have cubic inches, that means it's inches cubed, right? That's what that means. So you got to remember so who cares? Like, why do I need to know that? Okay, well, where's the hint? Remember that inches cubed, and here's your million, so you don't have to copy the purple, If I have x squared, that means x times x, not x times 2. If I have x to the fourth, it's x times x times x times x. If I have 2 to the third, it's not 2 times 3, it's 2 times 2 times 2. Well, this is the same idea. Just because it's not a letter or a number, the idea is the same. If I have inches cubed, I'm going to multiply the base times itself how many times? 3 times. So think about what I just said. I'm going to multiply inches times inches times inches. So where do I get that? Well, if I have right here the base is 6 inches. The width is going to be 2 inches. And the height is going to be 4 inches. And if you remember correctly, the volume of a rectangular prism is length times width times height. So can you see that I am multiplying inches times inches times inches? Wow, that is what I'm talking about, a hint. This one, they told you it is in square inches. So if it's square inches, you should have multiplied inches times inches. And that's where that comes in right there, okay? Inches squared. All right, anyways, so enough with the mini lesson. Let's put in the numbers into our formula or equation. So my length is 6, my width is 2, my height is 4. So if I do that, 6 times 2 times 4, hey, look at that, I get 48. So I got the same thing. And I'm telling you right now, this one is super important. It shows up a lot, even at the high school, 8th grade. Okay, length times width times height. It is one of the most common ones you're going to find. All right, moving on then. I hope that was enough lecturing for that one. Okay, but I did it because it's important, right? That comes up so much, guys. All right, next one. Let's see the figure below. Shows lines AD. All right, let me see AD. Where's AD? Right there. Okay, and then FC. Where's FC? FC right there. Perfect. Intersecting at point E. Where's point E? Right there. Okay. Based on the figure above, determine whether each statement is true or false. So, okay, we gotta be careful here. So a lot of this, guys, like I don't know if you'll have your tools. Maybe they'll have a highlighter tool for you available. I would hope they do. Okay, but you gotta look for that if you have access to it. Okay. So luckily I have the technology. This will help me figure it out. You guys should have scratch paper to work these out. Okay, so like I said, just a lot of things with geometry, you got to trace stuff. So here's what I'm talking about. The measure of the angle, okay? And it says it's in order. That's why I love geometry, because it tells me what to look for. I start at A and I go to E and then B. So I'm going to go from A to E to B. So can you tell, because again, there's my angle. Can you see they even told me the shape? It looks like an angle. Can you see it? There's my angle right there. So that angle plus this angle, CED. So I started at C. I went to E. I went to D. What angle is that one? That's 75. Okay. Is equal to 90. Okay, that's interesting. Is that true or false? Well, here's another mini lesson you got to know. You should know that if you see a box means 90 degrees. Okay? So this angle right here is 90 degrees. But that angle is not a part of my red and green one, right? So what's the other thing you're supposed to know? Well, the other thing is if you have a flat line is 180 degrees. Any straight line, basically. Can you see the straight line that I'm kind of thinking about right now? Look, boom, do you see that? So that straight line, I got 75. Then I got another 90. The question is, how much is this tiny angle? Well, if I know that the whole thing is 180, let's just use our math. I'm going to take 180. I'm going to subtract the 75. I'm going to subtract the 90, and that should give me my leftover. So 180 minus 75 minus 90, and I get 15 degrees. So this is 15. So if I go back to what I wrote here, or what I highlighted, the AEB was 15. My red one was 75. Is 15 plus 75 90? So 15 plus 75, yes, it is in fact 90. Now I'm going to leave those numbers there because I know those numbers have to be true. So I'm going to leave that there and just wait to see if I use them again. Okay? So let's go to the second one. So for the second one, I got FED. So where's FED? FED. So I got this one right there. FED is equal to AEB. AEB, which I already found was 15. FEB plus AEF. So AEF. Interesting. Okay, so that is a little tricky to find out. Okay, because I don't know what the purple and the blue one are. So is there a way I could figure that out? Well, I'm going to use the same trick I did earlier. I'm going to make this a straight line. And now I'm going to go from here to here. So how do I find the missing angle? I'm going to do the same thing. I'm going to take the 180, because that's the whole thing, and I'm going to subtract 75. So 180 minus 75. And that's going to give me 105 for that angle. Okay, let me clean this up so it's not totally messy. Is there a way to find this angle now? Well, I can use these two angles right here, right? So I already used 105 to find this one. So the whole thing is 180. I'm going to subtract 105. 180 minus 105, not 15. And I get 75, which means that this missing piece right here is 75. So now I'm going to clean all this up. Okay, so one of the things I'll probably remind you of, it's just easier to find all the measurements, and that's usually what I tell my geometry kids in high school. Let's just find all the angles that we can, and then it'll be faster to answer the questions. And you can see why, right? Because I'm doing all the work anyways. Okay, so I got a bunch of numbers. Let's do this again. Let's see from the beginning. I got FED. So this one right here is FED. What angle is that? That's 105. 105. Then I got AEB. So AEB, we said was already 15. And then AEF. So that's AEF. Well, that's 75. So is that true? Is 105 equal to 15 plus 75? So let's put it in a calculator. I don't think it is, but let's triple check. 115 plus 75. Yeah, that's 90. That does not work, so that is a false right there. Okay? And clean this up again. So we're going to do the last one. Again, with our highlighters. Makes my life easier. So AEB. So there's AEB. So the same little one. So that's 15. Then what's next? I got 180. Okay, that's just 180. And then I have minus BED. Where's BED? So that's BED. So that's this whole thing right there. So let's see. BED is 90 and 75. So 90 plus 75 equals 165. So now let's just use our numbers to find if this is true. So is 15 equal to 180 minus 65? Let's double check. 180 minus 165. Yes, that is true. Wow, that one was a lot of little busy work, right? You found, though, a little thing that we did a lot. We love, and I mean love in geometry, to use the straight lines because We see a lot of straight lines everywhere, and then we can always use the 180 to figure out missing angles. Okay, that thing never goes away. We do it so much, guys. Okay, 180 is like one of our favorite numbers in 10th grade geometry. Okay, next one, number 6. The image below shows equilateral, vocab right here, triangle whose base lies on the ray DC. Oh, that ray, actually, that's wrong. So there's my little typo. It should be AB. Okay, AB. Actually, sorry, give me a second. I'm going to make sure, because as I'm doing this, I am quadruple checking. You don't even know how many times to make sure I have the original work correct. Alright, so let's see. Give me a second, I apologize. So let's see, did I fix this already? Please tell me I did. Yes, I switched it to AB. Okay. Alright, sorry, I just want to make sure that when you're actually seeing the paper, you actually have AB on here. Okay, and you do, so I fixed it. Sorry about that. Okay, so the ray AB, and the ray looks like that. Can you see? It has an endpoint, and it goes towards the right forever. Okay? So based on the image, determine whether each equation is true or false. All right. So let's look. You know what we said, though? I said earlier, is there a way we could just find all the measurements? One of the things that's really special about this triangle is that it's an equilateral. Equilateral triangles tell me that all sides are congruent. What's special about congruent is that they are the same. And it also tells me that all angles are equal, aka the same. They're congruent. That's interesting because I told you one of our favorite numbers is 180, right? Well, one thing you should have learned in 7th grade is that the angles inside of a triangle all add up to 180 degrees. So if all of my angles add up to 180 degrees, that angle, and that angle should be the same. So I'm going to take 180 and I'm going to divide it by 3. I have to split it, which means that that's 60, that's 60, and that is 60. So then the trick is, well, how do I find the letter D? Well, D is adjacent, more vocab for you, which means it is next to angle C. So can you tell that if I combine C and D, I get a flat line right here? And what did we just say about a flat line? Those angles add up to, oh my God, another 180 degrees. So how do I find angle D? Well, I'm going to take 180 and I'm going to subtract the 60. So that's going to give me 120. So let me triple check right here. So 180 minus 60. And I do, in fact, get 120 degrees. Okay, so that equals 120. And just to double check, right, 60 plus 120 equals 180. So yes, okay. So I'm going to clean this up, make things nicer. So where are we at now? Do I have everything? Yes. So let's just use that to put in the numbers, right? We just got to substitute. So let's see. C was 60. Plus D was 120. Does that equal 90? I don't think so. It can't. 120 is already bigger. That's false. All right, C was 60. D is 120. If I add them, do I get 180? Yeah, I just said that. Let me just double check. 60 plus 120, that is 180. That is true. And then lastly, I got 180. D is 120, so subtract 120. Does that equal 60? So 180 minus 120. Yes, it does. All right. So notice, didn't that seem to go a lot faster, right? So again, strategy, and I always say good habits. Usually what students do is when you work out the problem, right, try to find all the missing information, your life goes a lot faster trying to answer the question itself. Okay, maybe you're like, oh, I didn't have to do that extra work, but I always say, hey, it was extra practice. It doesn't hurt, right? It just makes your skills a lot better. So here's another one that I'm talking about. Let's see what kind of question we got here. Excuse me. All right, so Lana saw the figure below and realized that if she knew the value of A, then B equals 180 minus A. What was Lana assuming about the image in order for her to find the value of B? Wow, that's very wordy, right? And this stinks because I'm like, I need more numbers. Why aren't you giving me numbers? This stinks, okay? All right, so let's read the answers and see if they make sense. KNM is a right angle. KNM, again, is a straight angle. KNL, MNL, so it looks like a lot of these repeat. So let's see the vocab that we have learned so far. KNM, because these are the same, so let's just trace it. So K, N, M. Is that a right angle? So a right angle looks like this. Does it look like that? Does it have 90 degrees? No. K and M is a straight angle. Can you see that K and M is a straight line? Yes, that is true. Now again, just because it's true, we have to think about what was Lana assuming about the image in order to help her find the value of B. Even though I know it's true, is it going to help me? I don't know yet. I just know that that's true. So let's do the other one. So what are we looking for now? Now I am going to focus on K and L. So K and L is this one right here. It looks like it's letter A or angle A. And M and L is, well, angle B. Okay. So what do I know about those two angles? Are they vertical? No. Again, a little mini lesson, right? Vocabulary is important in geometry. All right. So vertical angles, you already know two of them. 90 degrees. You know that that's 180. And if you have two angles like this, vertical angles are the same. So those are vertical. So the left one is the same as the right one, and the top is the same as the bottom. So can you tell vertical angles basically look like an X? Can you see that? Do those look like an X to you? Right, the red and the green? No, they do not look like that. And then the other one is complementary. So complementary angles have to do with 90 degrees. So if I were to split the 90 degrees into two angles, one angle plus that angle, together they would make 90. Do these two angles make 90 degrees? Does it look like this? Does this look like B and A? No. So that is also false. So in other words, the only answer it could be is B. Okay? By the way, just in case you were missing the last vocab word, they are in fact supplementary. And supplementary angles is basically make a straight angle, which means they are 180 degrees. Okay, all these things are connected, guys. Vocab. Okay. All right. Number 8. Okay, we did this already. Let's see what they want us to do. Very similar question, probably. So I am looking at. Actually, let me check something real quick. Yes, my headphones are on. Okay. Mr. Beltran has been working on his backyard for the last 2 years. Ugh. Make it 3 now. Okay. If you know what I'm talking about, then you're one of my kids that I've had the last 3 years. Because you keep asking me about my yard and I'm still not done. Anyways, his wife keeps telling him to hire someone, but he refuses. Of course I do. I am almost done. I have been almost done for 3 years. Okay. I'm like 90% away, guys. All right. I refuse because I can do it myself. All right, I'm gonna do it myself. The shape and dimensions of a yard are as shown below. All right, so that's how my yard looks apparently. All right, it's close enough. So enter the area in square yards. So I don't have to convert everything. Everything's in yards of the yard. Okay, it's not a big deal. It's almost the same as the first problem. So I'm going to go ahead and make my two rectangles. So it looks like right here, I'm going to keep this red rectangle. So let's make it neat here. There's my red one. I got a 2 by 6. Plus, let's make the other one, I guess, purple. Okay, why not? And for my purple one, it looks like, actually this one's even nicer because it's already done, right? The purple one is a 10 by 10. So this is actually, because if the 10's on top, the 10 is on the bottom. It's a square, so I got a square and a rectangle. Awesome. Now, what makes this even better is that our areas, just like before, are going to be length times width. So that's 6 times 2, which is just 12. Let me confirm that. 6 times 2. Why not? If I have a calculator button, I might as well. It's not going to hurt, okay? And then my other one is a 10 by 10. So if my area is length times width, it can be 10 times 10, which should be 100. Let me check just to make sure. 10 times 10. Okay, nothing funny going on there. So what is the total area? Let's go ahead and add those two up. So 12 plus 100 better be 112. And yeah, that's it. So not that bad, right, for this one. Okay, next one. So here's the thing, right? They're trying to make this complicated for us. But as I'm looking at it, I'm trying to think back to all the questions I had in 7th grade and all the shaded and non-shaded. And they're like, you have to find the shaded area. So you have to do subtraction. All this is going through my head right now as a student, right? Like the little things I know I have to do. The other thing I'm noticing is, okay, I'm noticing rectangles. That's easy. Length times width. I'm noticing triangles. So that is base times height divided by 2. Okay. And that's it for shapes, right? So let's see. What do we have to do? Let's see if everything I was thinking of is correct-ish here. So Mr. Beltran's front yard is made up of decomposed granite. Yeah, so that we call it DG. Except for 2 triangular concrete patches. That's true. The decomposed granite is shaded and the concrete is in white. So what do they want? Enter the number of square feet of decomposed granite. So what was that again? Decomposed granite is the shaded. Oh, I see. So it's another one of those questions. So what do we do here? So I want the whole thing. The whole thing is basically DG. So what do I have here for the whole thing? For my whole rectangle, let's see, the whole bottom is going to be 40, right? So that's a 40. Then what is the height? The height is, or the width is 16. So 40 by 16. But then I have 2 triangles, aka my concrete, that I have to get rid of. So actually, let me go ahead and move this to the left a little bit. Or I'm just going to make it a little bit smaller, actually, so it can fit. Okay. So what am I doing here? I got to get rid of this triangle. Right here. So I'm going to flip it around so it makes my life easier. It kind of looks like this, right? It looks like there's a 5 on the bottom. And then the height of my triangle should be the whole thing from bottom to top, so that's 16. Then I also have to get rid of this triangle. So what's the bottom and what's the height? So I have another triangle. The height is 9, and the bottom, aka the base, what is it? So they gave me other numbers, right? They said that from here to here, it's 22. Then I have 8 right there, so 22 and 8. So how do I find the missing one? Well, the whole thing is 40. So let's use our calculator. 40, take away 22, take away 8, and then my base of the triangle is just 10. So here's the thing. I say this all the time to my kids, right? My students in geometry. It looks way more complicated than it is. We got to break it apart. Look at one thing at a time, one shape at a time, one angle at a time, okay? And then things will be a lot easier. So let's go and find this. It's very simple calculations now because the area is length times width. So my area is 40 times 16. And that one, I don't want to do my head. So 40 times 16, not times. Okay, there we go. 640. Now remember, I got to subtract the triangle. So the triangle is base times height for the area over 2. So there's my base, there's my height. So I'm going to take that and say 16 times 5. And that gives me 80. And I'm going to cut 80 in half. So 80 divided by 2. And that gave me 40. And then I also have to get rid of the other triangle. So another base times height divided by 2. So I get 10 times 9 for 90. And I cut that in half. So if I cut 90 in half, I get 45. So let's do the final pieces here. I'm going to take 640. I'm going to subtract 40, and I'm going to subtract 45. So let's put that in our calculator. 640 minus 40 minus 45. And I get, well, it looks to me as a funny number, but whatever, 555. And I think I'll be happy with that number. That should be okay. And as I'm thinking about it, right, the whole thing was 640. Did I take out a huge chunk of my yard with concrete? No, right? It wasn't even half. It was like a smaller piece. I mean, there's 2 pieces. But remember, if I eyeball it, there's half, right? Like half and half. Those 2 triangles don't even fit into half of it. So does 555 sound reasonable? Yeah, I think that's okay. I think I did okay. All right. All right, let's see, 10, 11, and then we're done. Yay, okay, sweet. So since you are a friend of the planet, yeah, you better be, okay? We only have one. All right, until who knows when we start living somewhere else. Can't see it in my lifetime, maybe yours, maybe. We'll see. Anyways, off track here. So you're a friend of the planet, as am I. You decide to recycle a used cereal box and use it to ship a present to your grandma. Aw, aren't you nice? The figure below shows the dimensions of the box. Okay, so there you go. Can you picture it? Okay, I can see that. So enter the minimum amount of wrapping paper. So now I got to think about it. Wrapping paper is on the outside, right? In square inches, can you already tell what's going to happen? Square inches is inches times inches, or inches squared. So if you have inches squared, that usually means area. If you had inches cubed, that means volume. Okay, so you gotta know the difference. All right, so you need to wrap the whole box, the whole thing. Top, bottom, left, right, blah, 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 blah. So let's see. And it says round to the nearest tenth. Oh, they give me decimals. Ugh. And again, I say that, and you guys also hate decimals at all grade levels. But when you have a calculator, it doesn't matter. It's the same thing. They do everything for us as far as the calculations. So let's look at our box. For the box, we have a top and a bottom, and it's just a rectangle. Right? So I am looking at this one right here. And the top and the bottom, it looks like I have a 14 and I have an 8.25. Okay, not a big deal. So I have a 14 and 8.25. Then I have a right side and a left side. So the right side, can you tell it's this one right here? So it's another rectangle. And the bottom is 8.25, and the height looks like it's 2.5. And I'm running out of space here, so again, luckily with my technology, I can just scooch it over. And then what's missing, guys? I am missing the front and the back. So this rectangle, the front and the back, another rectangle. So it's 14, and the height of this one is 2.5. So what do we know about rectangles? The area is length times width. So length times width, another length times width, and another length times width. So for my area, I got 14 times 8.25. Then I have for this area 8.25 times 2.5. And the other one is going to be 14 times 2.5. So let's put all those into our calculator. 14 times 8.25. And I get 115.5. Then for my next one, I get 8.25 times 2.5. And I got 20.625. And then for my final one, I got 14 times 2.5. And I got 35. But here's the kicker. I only measured for the top. I only measured for the right side, and I only measured for like the front. Remember, there's two sides to it, right? Because it's a box. So what do we do with each of these numbers? As I'm stalling, hopefully you're realizing, yeah, you just got to double it, right? So I'm going to take all of these as I add them, and then I'm going to multiply by 2. So I got to double it. So let's go ahead and add these up. I got 115, not 11, 115.5 plus 20.625 plus 35. And I get 171.125. And then I got to multiply by 2. So take that answer. Notice how it's in blue, right? That's really nice with the calculator. I'm going to take the answer, which is 171.125, and I'm going to multiply that times 2. And I get a grand total of 342.25. Now here's the kicker. Did you remember it says to round to the nearest 10th? Our 10th place is right there. So the next number is going to determine whether we stay or round up. So do you remember what it was? Well, if you do, you should say, hey, look, since that one is 5 or greater, we're going to have to round up. So we get our final answer, total wrapping paper area of 342.3 square inches. All right, so let's clear this calculator up and let's do the last one. Yay. So you purchase new rims for your car that measure 22 inches in diameter. Okay, so can I picture that? There's my rim. It's a circle. So from edge to edge through the center, it's going to be 22 inches. That's what the quotation marks are. It's inches. Enter the circumference of each rim in inches. So notice, did you see inches squared anywhere? No. So that means you are not going to multiply inches times inches. It's just, you just have inches once. And then round your answer to the nearest hundredth. So what did we say earlier? The circumference is the pi. It is pi times diameter. So in other words, I got pi times 22 inches. So I'm going to go ahead and use, and did they tell me to use 3.14? They did not. So I'm going to use all of pi. I'm just going to put that on my calculator. Look, pi times 22, and I'm going to get 69.11503, blah, blah, blah. And this is me as a student, right? I always, just because I've done so much math, sometimes they'll tell me to round to the nearest thousandths, the nearest 10,000ths. Some teachers get crazy like that. So as a habit, I always go like a bunch of decimal places just because it's less annoying in the long run, okay? But in middle school, usually it's 1 or 2 decimal places, if I'm being honest. Okay, don't quote me on it, but yeah, that's from my experience. Anyways, what are we rounding to again? The nearest hundredth. That is 2 decimal places. So in other words, all I care about is this one right here. So the number next to it is a 5. So because it is 5 or larger, I have to round up. So now my answer is going to be 69.12. And again, those of you who did this and you used 3.14, let's see what that would have done. So 3.14 times 22, not a big deal. 3.14 times 22, let's see how far off they were. It was 69.08. Hey, look, it's already in the hundredths place. So either one of these should have been okay. All right. And that was our last one because that's on the other quiz. Yay. All right, so let's see. Quick recap. What do we have? Circles, super important. You guys got to see a lot of vocab, right? I did a bunch of little mini lessons here. This is one of those things that's never going to go away, okay? You need to know what 90 degrees is. You need to know vertical angles, 180 degrees, supplementary, complementary. Whew, so much vocabulary, guys. All right, I noticed they use the vocabulary. So if your teachers like to use little cutesy names like mine used to, okay, you got to remind them to use proper vocabulary. Now I feel like they're going to be mad at me for saying it, but it's the truth, okay? A lot of vocab here. And I think that's essentially it. All right, so till next time.